Hello, in this demo we are going to show you how to use Timeplus Enterprise to read the real-time data from multiple MySQL tables, apply real-time ETL to join the data together and put them into destinations such as S3 or GCS, and you can build a BI report using your preferred tools. And then we are going to use a typical data schema as the e-commerce. So there will be customers, they put an order, and each order includes multiple line items, and each item refers to the product. And the product might refer to some category. There might be some employee to support the customer, and there might be payment. But to simplify this, what we really care is that when the customer places the order, there will be a single record for the order, but there will be multiple rows for the order details. And we also needed to do the lookup to get the data from the product dimension table to enrich. And in the end, we want to build one big table. So this can be easily analyzed with your preferred BI tools. This probably can be easily done using a traditional OLTP, but how to get real-time transformation to combine multiple events from different tables as a single event in the second-level latency, this is the key strength of Timeplus. Let me walk through the details. So first, the MySQL database. So we have a MySQL database, and each table has a lot of columns. And if you check the real-time count, this number always changes because we keep adding data to this table. To get the real-time change, a common way is to set up Debezium as well as the Kafka Connect. So this is already set up. We have the Kafka Connect cluster, and there's one connector to read from MySQL. And this will put the data into the topic, such as order topic, the multiple columns, as well as the order details. Now in Timeplus, what we need to do that is we will set up multiple external streams. Each stream will read the data from different topic. For demo purpose, we only get the data from order details, and the products. If we check the data lineage, it clearly shows that we have multiple external streams to read from different topic, and have the materials view to read the data, apply the transformation, and we can apply join and use the materials view to send the data to the downstream system such as S3. So taking this example, this is the order details. We define the Kafka topic using a single column as law. We can use JSON paths to read from different attributes, convert the data type. Let me show you how the SQL is written. So for each Kafka topic, we define an external stream and get entire message as a string. Then we have this materials view to do the data extraction and making sure we set the seek2 to earliest to get the earliest event from very beginning. And we can also set up an external stream to read the product table. We put this as a mutable stream so that later on you can update the dimension data. And what is more interesting that is we can set up a dictionary. The dictionary is based on the mutable string we just set up, but it will provide an easy way for you to do the lookup. We use the materials view to load the data into the mutable stream. And similarly, we can set up a Kafka external stream for order stream details. To write the data into S3 or GCS, we can define an external table and using the endpoint as well as the credential, and we can put the file name template. Or you can also control what's the minimal size for the file in the object storage. Finally, this is the materials view as the data pipeline to read the two tables from the orders details and order, join them together using the order number. And you can also use the dictionary to look up to enrich the product code into the product name and the product ID. And because one order will include multiple order items, so you can use the aggregation to get the total order value, the number of items they ordered. Finally, you can write the data into the S3 using the external table. And one thing to highlight that is we use the emit on update to making sure that is most recent data will be right to the system without any duplicate events. Yeah, let's check the live data. So if we query the latest orders, you will see the data keep coming. Simulate the order details. You can build a real-time dashboard directly in Timeplus. So for example, this is the sales total. As you can see, this chart updates without any refresh. And the query behind it is simply query our materials view from the very beginning and get the total sum. As I said, you can also send the data to S3 or other system and build your BI report from there. So this is the GCS object storage. There's many files. Right now there are 231. If I refresh, there are more. And you can open one of the file. And you can see this is the aggregated event with the order number and as well as all the line item coming from multiple events in the other table. And because the data is in GCS, you can set up a BigQuery to get all the events using SQL. And you can run aggregation to get the total revenue, as well as the top customer who makes the most number of orders. And you can turn them as a chart like this. Go back to the overview. That is, we used common tools such as Kafka Connect, Debezium to capture the real-time data change, but they are in different topics. And the Timeplus can read all those Kafka topics and apply powerful join, enrichment, lookup, and anomaly detection, and put the data into downstream systems such as S3. Or you can build a BI report directly in Timeplus. That's all for the demo. Thank you for watching.